Good. Okay. Today we're gonna finish chapter 4. Okay, and then we'll talk about how do we start reviewing your test and how to prepare for the first test. Okay. Last time we went over all the reactions for aldehyde and ketones. Okay. Today we're gonna briefly talk about the first two types of reactions, review them, and then we'll just go in more details about the last reaction, the formation of acetal and hemiacid and acetal. Okay, so first, in this chapter, we studied the first reaction is the oxidation of aldehyde and ketones, which is the only reaction that distinguish these two types of carbonyl compounds. Okay, in oxidation, aldehyde will be oxidized to a carboxylic acid. Again, what happened here, you can understand this reaction as by inserting a what? An oxygen between the C and the H. And because of this H on the carbonyl group, the aldehyde can be oxidized. In ketone, the carbonyl carbon does not have the H. There won't be any oxidation reaction. So that's the first reaction. And then, of course, we talk about these two commercial reagents, Toland's reagents and Benedict's reagents. They're serving the same purpose. They are oxidizing agent. They're used to oxidize an aldehyde so that they give you positive results. You can tell there's an aldehyde group present in a certain compound. Okay, ketone will not give you a positive result, it will give you a negative result. So that's the first reaction. The second reaction is hydrogenation, or we can call it reduction. The reason we call it reduction is because we know during hydrogenation we're adding CH bonds. Okay, we're adding CH bonds. So in this reaction, as you can see here in hydrogenation or reduction of aldehyde or ketones, the carbonyl group is what? Is hydrogenated, is reduced by what? By adding hydrogen to the C and what? To the O. Again, of course, if you want to add hydrogen to the C and O, you need to what? Change the double bond to a single bond. So during hydrogenation or during reduction, an aldehyde or ketone becomes a what? An alcohol. Remember, after you add H to the O, we have what? We have an OH, so we get an alcohol. Now, depends on what type of carbonyl compound you start with, you end up with different types of an alcohol. For example, if you start with an aldehyde, which has a hydrogen on the carbon, if you add another hydrogen, you end up with a what? A primary alcohol. Right? You start with one carbon with a hydrogen, you add another hydrogen, this is CH2. And then that means this carbon only have one group on it. Or you can understand this way. For aldehyde, because there's a hydrogen, so on this carbon there's only what? One group. So after hydrogenation, this carbon with the OH still only has what? One group. So aldehyde hydrogenation or reduction gives a primary alcohol. If we start with a ketone, on this carbonyl carbon, we know there's no hydrogen, means on this carbon there are what? Two groups. Okay, two groups. So after hydrogenation, this carbon with the OH also has what? Two groups. So we get a secondary alcohol with a ketone, starting from ketone. Okay, starting with a ketone. So that's hydrogenation. And this is the reverse reaction. Okay, this is the reverse reaction of what we learned from chapter 3. Dehydrogenation or oxidation. Okay, oxidation. So you can see two ways. If you break the double bond, add hydrogen, we call the process what? Reduction, because you're adding CH bond. If you take hydrogens away, make the double bond, we call this process oxidation. Okay, oxidation. Okay, you're adding hydrogen, of course, we also call it hydrogenation. If you remove hydrogen, we call it dehydrogenation. Okay, Those are reverse process. Okay, reverse process. Right? Those are the ones we studied last week. The third reaction. Okay, third reaction. We're halfway there. We explained the reaction, but I want to go over this reaction again. Is adding alcohols to the carbonyl group. Okay, to be more accurate, to the carbonyl group is add to what? To the carbonyl carbon. Okay, to the carbonyl carbon. And if you notice that in the final product, both alcohols, these OR are from what? From alcohol. Both alcohols are added to where? To this carbon. What carbon was it? The carbonyl carbon. Okay, the CO double bond carbon. Do you guys see that? Okay, now let's go over this reaction again. I'll point out some important info about this reaction. Okay, first, in order to add alcohol, we change the double bond to a what? Single bond. And the H of the alcohol adds to the O. And the OR of the alcohol adds to what? To the C. Do you guys see that? Which carbon? Again, this carbon is what? That carbonyl carbon. You're only adding to those two guys. That's adding one alcohol. Okay, adding one alcohol. And we can add another alcohol by replace the OH with another what? OR. Do you guys see that? And in that we add what? Two alcohols. Again, this two OR in blue came from what? Two alcohols. ROH. ROH. Do you guys see that? You guys see that? After adding the first alcohol, okay, we call the product hemiacetal. After adding both alcohols, we call the product acetal. The reason they're both acetal is because this compound from what? Was from what? An aldehyde. Okay, an aldehyde. Why is an aldehyde? Because there's what? There's a hydrogen. That means there's a hydrogen here as well. You didn't change anything. You're only adding alcohol. Okay, the hydrogen was there. Still what? Still here. Okay, still here. And very similar with ketone. This is a ketone. On the carbon, there's no hydrogen. There are two groups on the ketone. And we can do the same way, adding first alcohol by what? Changing the double bond to a single bond. Again, hydrogen adds to the O. Oxygen adds to the C. You see that? We add what? Add the first alcohol. And then I can add the second alcohol by replace the OH with what? With another OR. See, two alcohols added to what? To the C. And because those are from a ketone, so we call those ketone. The one with only one alcohol added is called hemiketone. The one with two alcohol added, a ketone. Does it make sense? Again, in the end, the OR is from where? From alcohol. They're added to where? To that CO double bond C. Just keep that in mind. Okay, keep that. Okay. Next. Take a look at these four structures. Hemiacetal, acetal, hemiketone, ketone. Like we mentioned last time, these four structures are very unique in organic chemistry. The reason they're unique because all these four structures have what? A carbon single bonded with what? Two oxygen. Do you guys see that? CO, 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 CO. Do you guys see that? Those are very unique. Okay, the reason we spend too much time with studying these structures, you're going to see them again when we study carbohydrates. Okay, carbohydrates exist as hemiacetal and acetals. Okay, those four structures are very unique, again, by what? With a carbon single bonded with 2 oxygen. Okay, with 2 oxygen. Now, how do we distinguish acetal versus ketone? We look at what?
Hydrogen.
We look at that carbon. Is that right? We look at this carbon. This carbon was what? The carbonyl carbon. Remember that. We're adding what? Adding the O to that carbon. If the carbon has a hydrogen on it, we know these are from what? Aldehyde. So they're what? Acetals. If on the carbon there's no hydrogen on it, we know they're from ketone. And they're what? Ketones. That's first you know what they're from. By looking at this carbon, you can easily find the carbon. Which carbon? Again, the carbon with what? 2 oxygen bonded to it. And then, after you know which one is acetal, which one is ketone, you keep looking at this carbon. If there are 2 O's, one of them is OH, means what? You only have 1 alcohol added. Is that right? So we call what? We add a hemi. If they're both OR, again, R is a carbon, then what? There means you have added both alcohols. Then no hemi in their name. Does it make sense? Okay, let me put this structure next page on the book on there. You tell me, guys, what are these 2? What are these 2? What are these 2?
Ketones.
They are acetal or ketones?
Ketones.
Keto or acetal? Ketones. Why ketones? Because on this carbon, again, which carbon? The carbon with 2 O's. Does it have hydrogen on it?
No.
Christina, does it have hydrogen on it? On this carbon? Do you see a hydrogen on this carbon? No. If no hydrogen means it's from what? A ketone. If from aldehyde, there must be a hydrogen on it. So both are ketones. Right? And then you keep looking at these 2 O's. This O is a what? OH, not alcohol. This is an OH. That means this is hemiketone. This is what? Ketone. Does it make sense, guys? Make sense? All right, let me put this structure on the board. Now we see more about this structure. Okay, this is the ketone here. Okay, the ketone. Again, why is a ketone, guys?
No hydrogen.
On the carbon has no hydrogen. So it is. This one was from what?
Ketone.
From a ketone. And because on the O, they're both O are what? OR. Do you see that? That means there are 2 alcohols added already. If there are 2 alcohols added, then this is not hemi. This is what? Just ketone. Make sense? Okay, let's take a look at the structure. We know this is ketone, meaning what? 2 alcohols are added to the ketone. So let me ask you, can you tell me what the structures of the alcohols and the ketones are? That means what ketones and alcohols are added together to make this ketone? Can we figure that out? Okay, let's take a look. First, again, this OR from what? This OR, OCH2, CH3. This OR was from what?
Alcohol.
From alcohol. Is that right? Do you guys agree? This part here, this and this, they're both from what? Alcohol. So this from an alcohol. So how do we get the structure of the alcohol?
We just add OH.
We add a what?
Add OH, so
What is alcohol? ROH. So what do we need to add this?
OH.
We have an O already, right? What do we add to this one to get the structure of the alcohol?
O. No. OH.
Add what?
And OH.
Not add OH.
The R is there.
This is OR already, right? What is missing to make it an alcohol? H. This is the alcohol. Does that make sense? This is the OR. Is that right? You add an H, you make what?
Alcohol.
The alcohol. Do you guys see that? Okay, let's turn back to the blue. Here, you see that? This is what? OR. Is that right? You add H, this is what? The alcohol. You guys see that? So you can actually tell what alcohol it was from. Now we know the one in box were from alcohols. How about these three? The atoms are not in the box. They're from what?
Ketone.
From ketone, right? And where is the CO double located?
The middle carbon.
Carbon. So what is the ketone? CH3CO. Is that right? Is that the ketone? How do we make the ketone? Okay, do what? Take the alcohol away. Then what? Make the double. Remember, there was a double one here. CO double one here. Is that right? So if I give you a structure, you can easily tell what makes that acetal or ketone. The OR was from what?
Alcohol.
From alcohol. All you need is an H back to the O. That means you need to go back to the alcohol. Is that right? And then what? Look at that carbon with the two ORs. You need to put the double CO double one back to get what?
Ketone.
To get the ketone or aldehyde back. Okay? So that's more about this. We have more practice. Okay, come. Let's take a look. This is what we just did. Here. Two more. We'll do them all a lot. Okay? First, the one on the left. Okay, the one on the left.
This is a hemi.
What is it?
Hemi
Don't look at the one on the right, only one on the left. What is it?
Hemiacetal.
She said hemiacetal. Do you guys agree? All agree? The one on the left, here.
So there's two O groups, and then there's R dash slash carbon.
There's no H, so
There's no H. Think again.
but there's two O's.
Two O's, right? We said this carbon was two what? Two O's. So it's what? One of those four. Is that right? Hemiketal, ketal, hemiacetal, acetal. So what is it? First, whether it is an acetal or ketal, which one?
Or it's,
Take a look at this carbon. Does it have a hydrogen on it?
1, 2, 3. Yes, one hydrogen.
Does it have a hydrogen on it?
One hydrogen.
Yes. Then this was from a
Aldehyde.
aldehyde. If it is from an aldehyde, this is a acetal, right? First, it's not keto, it's from aldehyde, it's an acetal. Number two, these two O's are both ORs or one of them is an OH?
They're both ORs.
They're both ORs, so this is a acetal, not hemiacetal. Does it make sense, guys? Does it make sense? This is an acetal. Okay, let's take a look at the acetal structure again. Okay, first I copy the structure on the right. Okay, acetal structure. We know these two ORs again are from what?
Alcohols.
Alcohol. So what is the structure now? What alcohol it is?
Ethyl alcohol.
What is the alcohol? The alcohol is OCH3. Is that right?
Yes.
This is one carbon. Is that right? So CH3O what?
H.
OH. This is methanol. Is that right? Do you guys agree? That's the alcohol. These two are from an alcohol. How do we make an alcohol? Just OR add what?
H.
Add an H. Now what is an aldehyde? We know this is from an aldehyde. This is the acetal. So what is the aldehyde? Or what was the aldehyde? How do we get it? How do we get it?
Double.
we
got
take
double
the OR and OR what?
dash.
Away, is that right? Put what?
Um,
Put the CO double bond what? Back. Of course, there's a hydrogen on it. Now we can show it. Does it make sense? Does it make sense? If not, let me know.
Can you go over it one more time? Thank you.
O. This is the carbon with what? With two O's. We know that carbon was what? The aldehyde carbon. Is that right? So all we need is, remember they're added two ORs. All we need is what? Takes two ORs away. Then what? Put the double bond back. That was the aldehyde. Okay, there was a hydrogen here. Now, because it's an aldehyde, we show it. Okay, there's a hydrogen over here. Okay, there's a hydrogen. So if we ask you, what is the aldehyde and alcohol for that structure? These two are. Okay, these two are. Does it make sense, guys? Does it make sense? Come on. Not I can explain. All right, on the right. Okay, on the right, this guy, what is it?
So it's a hemi, but
Hemiacetal? Do you guys agree? He says hemiacetal. Okay, again, we're always asking two questions, right? You ask yourself those two questions, you can answer what it is. What are those two questions? First is look at the carbon with what? With two O's, is that right?
yes.
Does this carbon has hydrogen? Yes or no?
Yes.
Yes, so it's from
Aldehyde.
an aldehyde. Okay, this is from an aldehyde. If from an aldehyde, we know this is what? Acetal. Is that right? Then take a look, these two O's. Are both OR or one of them is OH? OH, so this is a
Hemi.
hemiacetal. Okay, this is hemiacetal. Is that better enough? Clear enough for this? Okay, this is what we have done already. Okay, no matter hemiacetal or hemiketal, they can be turned back to their aldehyde and ketones, aldehyde or ketones with their alcohols by adding acid. Okay, they can be changed back. Okay, top reaction, acetal. You can see that? Two ORs on the carbon with hydrogen. If we treat it with an acid, both alcohol will become what? Alcohol. Do you see that? RO add what? And an H. And then just take these away and put a what? Double them back. Remember, this carbon, just say many times, this carbon with those two R's added to our what carbon? The carbonyl carbon. Okay, they're just added with two alcohols on it. Okay, if you start with ketone, the same. Two OR can be what? Taken away to make their alcohols, and then put a double bond back to the what? To that carbon. Okay, you always need to put your eyes on this carbon. This carbon was what carbon?
Carbon.
The CO double bond carbon. The difference between these two is this one had two ORs added to it. Those two OR came from what? From
Alcohol.
alcohols. Does it make sense? Okay, and one thing you remember, if you write the structure of this, make sure it's the O attached to the C, not the R. Okay, you're adding O attached to the C. Good? Okay, I think that is all for it. Here are this is a summary for the reactions we learned in this chapter. Oxidation, hydrogenation, and acetal and hemiacetal formation. I put in different colors. You guys can see, okay, what's happening. Okay, what's happening.
take a picture because it's not color coded in the lectures.
Oh, this one is not included?
It's not color coded, like it's
Oh,
all in
okay,
black.
okay. Yeah, they didn't print out in color. Okay, in fact, let's use this one to do it one more time. Okay, I know you guys we have time today. Okay, CH3OH. Okay, these two. Let's say we're adding the alcohol to the aldehyde. Okay, adding the alcohol to the aldehyde. Okay, take a look. You have color coded here. You guys tell me what to do. Okay, first, I copy the aldehyde structure on the right. So if I want to add alcohol, what do you do, guys? You guys go with me. Come on. Remove the double bond. Good. And then what?
Add the
Check
OH.
the color.
Add the OH and then
Add what?
H to the
H of the alcohol to the
oxygen.
O. And then what?
Add the OR dash to the
The
carbon.
OROCH3 to what?
To the carbon.
To the carbon. Do you guys see that? That is called hemiacetal. Is that right? And then I can add, let me copy the structure again. Sorry, I need to write like this. What do we do if we want another alcohol added? Do what?
H to the O.
What do we do?
You add another.
How do we add another OR?
Remove the H and then
Remove the what?
the H from the O.
This top.
Remove the what? Think again.
The OH.
The OH. And then what?
Make it a
Make another OCH3. Not the H. Never touch this H. This H was which H? The aldehyde H. You guys see that? Is that right here on the left? Take a look. Remove the double bond to a single bond. H to the what? To the O. OR to what? To the C. Do you see that? If I want the second one, what happened? What's the difference between these two? The OH becomes what?
Or
Another OR. Is that right? All right, that's all for the reaction in this chapter. Can you stop?
I have a question.
Yes.
So like